part two of our festivities. Now what we're going to do is try to determine the mass of a sample of material, assuming that we know what that material is. So I have here a sample of material. Again, back to observations. I observe that it's kind of heavy. That's an observation. Cool to the touch. Looks metallic, and it's rather brown. So I'm hypothesizing that this is copper. And if it is copper, and if I can determine what its volume is, then I should be able to predict its mass. So to predicting its volume, I have a graduated cylinder set up, and it's showing 148 milliliters. So now I'll see what the volume is. And I'm showing 180. Yeah, 180 milliliters. And that looks like 32 milliliters to me. All right, so now I'll set up an equivalence with the known mass density of copper. There's my basic setup. I'm going to convert everything to small units. So I'm going to turn kilograms to grams. Kilo is 10 to the third, times 10 to the third is 10 to the sixth. One cubic meter is 10 to the sixth milliliters. So now I'm set up. Do cross multiplying. Eight 0.89 times 10 to the 6 grams times 32 milliliters equals 10 to the 6 milliliters times X grams. Double check it, make sure I haven't left anything out. Grams and grams, 10 to the 6 milliliters, yeah, it's all there. I'll do some cancellation. And if you do it the same time, the same way every time, this is a trick with doing a lot of this stuff. Granted, we're doing this remotely and rather abstractly, but the trick is to don't skip steps. Do it the same way every time, and you'll go wrong far fewer times. So what do we have? 8.89 times 32 equals X equals I got 284.48. My answer. So, this sample of copper should have a mass of 284.48 grams. So, I'll dump the water out. And I'll dry off my sample. And just to make it interesting, I'm going to set up my scale, my balance. Actually, this is a triple beam balance. 284.48, which actually goes to 5 there. Okay. 284.5. All right. And I'll put the sample on the balance and see what we get. So, 1, 2, 3, 4. Here comes number 5. I always get nervous here. I feel like I ought to be betting beers or something. Not quite. So let's see how close we are. Oh, not that far off. So I'm showing 282.5. For my actual, my predicted is 284.48. So what we'll do is, let's see how close we got here. So, the difference between the two, 284.48 minus 282.5, the difference of 1.98. I'm going to divide that difference by what I predicted. And that equals 0.00 696, which comes out to 0.696%. So I was within 1%. What do you know? Physics works. So yeah, there it is. And the other thing to keep in mind is you have to imagine what would happen if we did this test over and over and over again, say 100 times or 1,000 times. You know, the plus or minuses here. You can see that over time, those would get closer and closer and closer to a 0%. And that too is something to keep in mind when you want to evaluate how science works. When we get to something that we call a theory, it means that it has undergone thousands of tests where we refine the numbers and gotten down to mere decimal points of percentages of accuracy. So there it is. How to determine the mass density of a material, and how using what we know about mass density, we can predict the mass of a certain material. Different ways of evaluating the same basic idea of mass and volume. All right, so there's that. More later.